Logarithmic functions can be given by the help of exponential functions. Most of the time, if you would like to find out the value of the exponential function, it is easy to use the logarithmic feature to figure out, okay, what the value will be. So in this definition, as you see, when you have the base of a, and then the exponent, right? This is my base, and then this is the exponent, and then this is the value you will get right after this calculation. But look at it, how am I going to convert into the logarithm function? Base will go here, okay? Still it is going to be base, but your exponential right there will be here, and then your result, okay, your result of this calculation will be right there, your logarithm value. And then, of course, we need to use the positive a value, since the exponential function definition requires us. A should be different than 1. And also, as you know, right, that this calculation always will be positive. That's why, okay, you need to keep the x values positive value. Let's look at the graph of these two functions. If you see, right, look at this graph. This is the graph of your exponential functions, you will remember. And then that was 1, right? And then you may just check out the 1, which will be the a here, correct? And then if you look at right, the logarithm function, this is kind of the inverse of the y is equal ax. It is really the inverse function of the exponential function, and then this is my y is equal x line. So basically the graph of the logarithm function will be the symmetrical about the y is equal x to the right y is equal a to the x function. Here this is the value, which is 1, and if you put here the a, okay, a will give you again the 1 value, okay? That will be your value, how you are going to calculate the logarithm function. Let's look at the logarithm function features, okay? Some of the features we can use for calculations. These rules actually comes from the exponential rules. We can easily, okay, prove those using the exponential rule. Look at the first rule. First rule says if you would like to write the multiply these two numbers, you can write the add these numbers. Please don't confuse with this one, since that's the common mistakes students do. Logarithm x plus y is not equal logarithm x plus logarithm y. There is no such a feature. Please don't do such a mistake, okay? That's the common mistakes. People always do that. I have, okay, similar features. Look at it for the quotient. And then I also have the power rule. What it says, if you have the power of your, right, the logarithm value, you can just, right, take this out. You can put front of the logarithm. And then you can change its base, okay? And with the different base, you may want to calculate the logarithm. That's how you do it. And then also, if you want to use, right, the logarithm to solve an equation, and the logarithm's value after the same, under the same base, okay, they will be equal. Let's look at some example, okay, to see these features, guys. First, I would like to show you, okay, how you can convert an exponential to the logarithm. As you see, if you wanna use, right, the logarithm instead of the exponential, base is gonna be my base of your, right, of my logarithm, and then the value, right, on the exponent needs to go right on the right hand side of the equation, and then this guy will be right my logarithm value. Okay, that's how you can think of, right, how you can write it off. And then I will do the same thing here. Look at that. The base will be my base, right? But I will change the the exponent, and with the value of my exponential value, this will go here, right? And then the exponent will go to the other side, okay? That's how you can do it. Maybe we can use some logarithm feature rated to calculate some values. Look at that. If I would like to calculate logarithm 2, 1 to 28, how would I calculate this one? First of all, you may wanna write the 128 as a multiplication of two numbers, but I'm gonna prefer to write this guy as a exponential of the 2. If I have the exponential of the 2, right, I know from the power rule in the table I gave it to you, I can write this one in this one. I can just drop the 7 right in front of the logarithm 2 by 2. So can you tell me what is it? So you can basically use the exponential, since basically what you are asking, if you want to turn this one into exponential, you are asking this one, whose exponent will give you the 2? What exponent would give you the 2 if you have the base 2? That would be always 1, right? So this is just going to be 1. And then the logarithm result will be just a 7. So we can basically give another rule, guys, here, right? This is the rule, logarithm, right? The logarithm, you can look at the graph, we did the same thing. A to the A will be always 1, since, right, the exponent of 1, A is going to be always 1. The other one, look at the logarithm A to the 1, right? Basically, you are asking again, right, what exponent of A would give you the 1, which is 0, as you know, right? That these two rules are so important. We are going to be always using these. Logarithm is so useful to solve some equation, especially when you have the exponential equations or the normal equations. Sometimes you can take the logarithm of each side, and then you can just apply this rule, guys. What it says, if you have the logarithm on both sides with the same base rate, the value of the logarithms will be same. Let's solve some examples. Look at this example. Logarithm 3 to the x plus logarithm 3x minus 2, right, there with the base of 3, which is equal logarithm 3 to the 3. Okay? So what is x, right? That's my problem. For the left-hand side, what I can do, since I have the plus here, I can combine using the multiplication rule. So the multiplication rule says you can just multiply this x times x minus 2. That's what I'm going to do. On the right-hand side, look at the logarithm 3y3, right? It is going to be 1, right? Since if I have the same base and then same value, which is going to be always 1. Another thing, look at that here, what I will do, I can use the exponent. Exponent would tell me 3 to the 1, which it would be equal x times x minus 2. But you may ask, right, why didn't we use the equation, logarithm equation feature? You can do it in that way as well. Look at that. If you kept this one in this way, as you see, if you have the base, same base, you can have the same value. So from here as well, I can have the same equations. As you see, they are equal. So you can solve. You can go either way, and then you can solve one of them. Okay, great. And how am I going to solve this? You know from the review section, if you would like to solve the quadratic equation, you need to use either the factorization or the quadratic formula. And I'm going to go ahead and I'm going to use the factorization, correct? X minus 3, x plus 1, which is equal to 0. X is going to be equal 3 either, right? Or x is going to be equal negative 1. But as you see here, x cannot be negative since I cannot calculate the negative logarithmic value. That is why x1 should be equal to 3. Another equation, another example would be this one. 3 to the x or plus 4, which is equal 1. So yeah, I'm going to take the logarithm from both sides with the base 3. Why I'm doing this, and it's going to help me to solve in a simple way. As you see, the left-hand side, the right-hand side is just going to be 0, but the left-hand side, I can use the power rule, to drop the x plus 4 to the front. So logarithm 3 by 3. So logarithm 3 by 3, is going to be equal 1. So x plus 4 should be equal 0. If x plus 4 is equal 0, x should be equal negative 4, right? That's how I use the logarithm. Look at that in exponential equation. You can just take the logarithm from both sides, and then you can just use the logarithm features, to get a normal equation. It will give you your linear or the quadratic equation, which is going to be simple, to solve than the other type of equations. So if you try the negative 4 here, which is going to be 0, 3 to the 0, which is equal 1, we are correct.